In this video, I am going to discuss some new implications called converse, inverse, and contrapositive. From my earlier videos, you know that an implication is a logical connective that involves two or more simple statements like P or Q. Let's take a look at the truth table for implication P implies Q. It is true that when P, which is called hypothesis, and Q, which is called conclusion, is true. If hypothesis is true and conclusion is false, then P implies Q is false. These are the only two cases when P is strong, meaning it is true, and we can make some valid conclusions. In other cases, the P is false and we could not determine the outcome Q, so we say it is logically true. So here I suggest you to watch my video related to implication and biconditional to understand in more detail. If P implies Q is the implication, then Q implies P is the converse preposition. Let P be the statement, it is raining today, and Q be the statement, I don't go to school. P implies Q is the statement, if it is raining today, then I don't go to school. The converse of the statement is, if I don't go to school, then it is raining today. Let us draw the truth table to see how output look like for both statements for all the input combinations. There are two variables P and Q, so the number of rows in the truth table is 2 raised to 2 equals 4. The columns are P, Q, P implies Q, and Q implies P. Now we must enter truth values for each columns, starting with P and Q columns. Enter true, true, false, false in the P column and enter true, false, true, false in the Q column. For the next two columns, we need to evaluate the entries using P and Q column values. If P is true and Q is true, P implies Q is true. If P is true and Q is false, P implies Q is false. If P is false and Q is true, P implies Q is true. If P is false and Q is false, P implies Q is true. We must evaluate the column Q implies P in a similar manner. If Q is true and P is true, Q implies P is true. If Q is true and P is false, Q implies P is false. If Q is false and P is true, Q implies P is true. If Q is false and P is false, Q implies P is true. Next implication I want to discuss is inverse. If P implies Q is the implication, then not P implies not Q is the inverse. From our earlier example, P implies Q is the statement, if it is raining today, then I don't go to school. The inverse not P implies not Q is the statement, if it is not raining today, then I go to school. Therefore, inverse is opposite of P implies Q statement. Does this reflect in truth table? Let us find out from the truth table for inverse. Now we are already familiar with the truth table for implication. We just need to add 3 more columns in it, which is not P, not Q, and not P implies not Q column. The entries for not P column is opposite of P column. Enter false, false, true, and true. Similarly, not Q column is opposite of Q column. Therefore, enter false, true, false, and true. To evaluate the not P implies not Q column values, we use the not P and not Q column. When not P is false and not Q is false, the not P implies not Q is true. When not P is false and not Q is true, the not P implies not Q is true. When not P is true and not Q is false, the not P implies not Q is false. When not P is true and not Q is true, the not P implies not Q is true. When we compare the P implies Q with its inverse, not P implies not Q, both are different. But the output of converse is same as that of inverse, which means that they are logically equivalent. Therefore, we have a new logical equivalence. Q implies P is equivalent to not P implies not Q. The statement, if I don't go to school, then it is raining today, and if it is not raining today, then I go to school means the same thing. The contrapositive of implication P implies Q is not Q implies not P, which is like taking inverse of the converse statement Q implies P. If P implies Q is if it is raining today, then I don't go to school, then the contrapositive statement not Q implies not P is if I go to school, then it is not raining today, which is similar statement. But does the truth table validates this as equivalence? To find out, we draw the truth table for contrapositive statement. We just need to add one more column to our existing truth table, which is not Q implies not P. To evaluate this column, we use the not Q and not P column truth values. So if not Q is false and not P is false, then not Q implies not P is true. If not Q is true, not P is false, then not Q implies not P is false. If not Q is false and not P is true, then not Q implies not P is true. If not Q is true and not P is true, then not Q implies not P is true. If we compare the output of column not Q implies not P to other columns, it is exactly same as P implies Q column. So we have another identity, as we already know, not Q implies not P is equivalent to P implies Q. There are other identities for implications that I will try to prove in my next video.